Anastasia, this is Scott. How do you read me?
Loud and clear.
Copy, I read you 5 by 5. Hi folks, welcome to today's lecture. We're going to get started in just a minute. Come on in, make yourselves comfortable, and we're going to have a great talk today. All right, a couple announcements before I hand over to our speaker. I want to say hello to members of the Philadelphia Association for Critical Thinking, our skeptical neighbors to the north, who are joining us online today. Congratulations on your organization's 25th anniversary this year. Well, ladies and gentlemen, welcome to today's online lecture presented by the National Capital Area Skeptics, NCAS, also known as NCAS. I'm Scott Snell, NCAS president, speaking to you from my house in Greenbelt, Maryland, just outside Washington, D.C. NCAS serves the D.C., Maryland, and Virginia area and online as advocates for science and reason. We promote the scientific method, rational inquiry, and education. Find out more about us at ncas.org and also have a look at our collection of past NCAS lectures at our YouTube site. You'll find interesting lectures on topics such as psychic detectives, Scientology, how to read a medical study, and our most viewed video, The Collapse of Civilizations. That collapse was back in 1177 BC, not now. Anyway, NCAS has been hosting our monthly public lectures since our founding back in 1987. This is our first online lecture, originally scheduled for today at our usual Bethesda, Maryland venue. We also host lectures in Northern Virginia and events in DC. All are free of charge and open to the public. Now, before I introduce our speaker, I do want to give you a quick run through on how we'll handle questions and answers today. To the right of your screen, of your video display, you'll see a chat window. Post your questions there. You have to sign into a Google account in order to post. And if you would, include the name of your city or town and post your questions anytime. Our speaker will answer them after she finishes her presentation. All right, it's my pleasure to introduce Dr. Anastasia Bodnar. She's a geneticist who is the policy director of Biology Fortified Incorporated, a nonprofit organization that fosters conversation about issues in food and agriculture. At the National Institutes of Health, she conducted special projects in science policy, science communication, and legislative affairs. And she's currently a regulatory risk assessor at the US Department of Agriculture at their Office of Pest Management Policy. If you've ever seen the documentary SciMoms, she's featured in that as one of the founding members of that group. NCAS had a SciMoms event a couple of years ago. She'll be speaking to us today from her home in Alexandria, Virginia, on evaluating news media coverage of health risks. Ladies and gentlemen, Anastasia Bodnar.
Thanks so much, Scott. I'm really pleased to be able to speak with you today, despite everything that's going on. I'm so glad that we were able to turn this into a video lecture. So I'm going to pull up my presentation for you really quick. So as Scott mentioned, I'm Anastasia Bodnar. I have a long background in risk assessment and risk communication, including with the small science communication nonprofit, Biology Fortified, and with SciMoms, which is a project with the goal of sharing science-based information to parents specifically. So today I'll talk about how to evaluate media coverage of health risks. As Scott said, the National Capital Area Skeptics and I had decided on this topic months ago, but it seems particularly important today in the face of so much information and misinformation about the current pandemic. So before I get started, I just need to note that my opinions are mine and cannot be blamed on my employer. So let's get started. In this talk, I'll briefly introduce the concepts of hazard, exposure, and risk. Then I'll describe some common issues with risk perception and risk communication. I'll introduce the chain of exaggeration, single study syndrome, and the pyramid of evidence. And finally, I'll present a case study on glyphosate. You'll notice on my slides that I have links at the bottom of a lot of them, so that you can look more into each topic if you'd like. And also keep an eye on the SciMoms website, SciMoms.com, where I'll be posting a blog post in the coming weeks with content similar to what I'm presenting today. And while you're there at SciMoms.com, don't forget to sign up for our newsletter. So let's start with the definition of hazard. A hazard is something that has the potential to cause harm. A shark, for example, can certainly cause harm, but most people are never near a shark, so it's not helpful to simply state that a hazard exists. Risk, on the other hand, considers the likelihood of harm from a hazard. Hazards only become risks when there is exposure, such as swimming in the ocean near sharks. These concepts can be summarized in an equation. Hazard times exposure equals risk. Hazard does not change, but we can reduce risk by reducing our exposure. Components of exposure include frequency, duration, and amount. Some risks are riskier than others due to the details of the hazard or the details of the exposure. For example, red wine can be part of a healthy diet, even though we know that alcohol is a health hazard. By reducing how often and how much we consume alcohol, we reduce the risk. Next up is risk perception. We tend to only pay attention to certain risks. We only see part of the full picture. Risks seem much worse when they're unfamiliar, such as genetically engineered crops, or man-made, such as bisphenol A in plastics, or things that we can't control, such as pesticide residues in food. That's why these things can seem so scary, even if they present a relatively minor risk. We tend to disregard risks that we're used to, such as salmonella, things that are found in nature, such as fungal toxins, and things that we can control, like eating more fruits and vegetables. That's why these risks often seem less interesting to us, even though they can have a potentially more profound impact on our health. We can think about risks as a landscape, with bigger risks as trees and smaller risks as grass. So air pollution, lack of exercise, smoking, not eating enough fruits and vegetables, and heavy drinking are larger risks, and they tower over the minor health risks, such as pesticide residues and fungal toxins in food, and coffee and red meat. Lastly, we rarely consider the risk of doing nothing or the risk of alternatives. For example, there's been a lot of concern in recent years about bisphenol A or BPA in plastics. Whether exposure from something like a plastic water bottle amounts to much risk is another question. But due to public concern about BPA, manufacturers started removing it from plastics a few years ago. They replaced BPA with BPS. But the risk of the alternative wasn't considered. Now people feel a lot safer, but BPS may actually present more of a risk. It's less studied than BPA, so we don't know as much about it. Because of these innate problems with risk perception, accurate risk communication is even more important. Unfortunately, problems of risk perception can often be worsened rather than improved with risk communication, depending on how it's done. Risk communication is defined by the World Health Organization as the real-time exchange of information, advice, and opinions between experts and people who face a threat to their health, economic, or social well-being. Here, Dr. Fauci from the National Institutes of Health communicates the risk of COVID-19 at a press conference. We could, of course, have a whole separate discussion about the wildly different risk communication strategies that we're seeing about coronavirus. But let's press on. Who is a risk communicator? The obvious includes scientists and health professionals. And then we have government and intergovernmental agencies, especially those with public health related missions. Universities, especially those with public-facing programs like Extension. And many nonprofits have significant risk communication roles, from very small ones like my own Biology Fortified, focusing on risks in food and agriculture, to much larger ones, and they typically have a focus on a specific topic. Journalists, of course, play a huge role in taking information from all of these sources and making it more available to the public. Lastly, let's not forget people, probably many of the people watching this today, who take the time to provide fact-based information to their family and friends. Now, each person or organization here can help provide clarity or muddy the waters. But in many ways, it's journalists that have the most power, if only because of their ability to communicate with large numbers of people. People rely on journalists to provide information about risks. They can help people to understand scientific concepts that are important for our daily lives. And journalists can help describe how science is used in policymaking. They are uniquely positioned to put many pieces of a story together into something coherent. But it's easy to make mistakes, including some pretty basic ones, intentionally or unintentionally. It's easy for a story to get bigger than it is. Somehow the fish is always this big rather than the actual size that you caught. The same often happens when reporting about risks. First, word choice matters. We rarely see articles that say, "Don't worry, the risk is low." Instead, we see headlines that are designed to stoke fear so that we'll share them again and again. For example, here we see a headline telling us that ramen noodles can cause Alzheimer's disease. Articles like this abound on websites that are trying to sell everything from crystals to herbal remedies. But even the most prestigious news sources can have alarmist headlines. Here we see The Guardian reporting that your children's breakfast is full of pesticide, and they're far from the only source that does this. Image choice also matters. The pictures that accompany articles, especially the preview images that appear on social media, can color how we perceive the information that's in an article. Biotechnology is a perfect example. We've all seen these silly images of someone wearing dishwashing gloves, injecting unknown liquids into fruit. That's not how biotechnology works. Instead, it looks a lot more like this, but these baby plants aren't as scary. The media exaggeration about health risks has been well documented. In a 2018 study, public health researchers identified 50 academic studies that associated an exposure to something with a health outcome. They found the most shared media articles about those studies. For example, a journal article showed an association between childhood cat ownership and schizophrenia. It was an interesting study, but the media article definitively linked having a cat with mental illness in humans. Not an appropriate conclusion based on that study. Similarly, a journal article showed that ventilation in the workplace is important, a good finding. But the resulting media article links climate change and increasing CO2 levels with a decrease in people's ability to make decisions. They made it sound a lot scarier than the original scientific article presented. Those same researchers found that only 4% of the studies in their sample set had strong claims that were actually verified by the evidence in the paper. Yet the media reported that 44% of those studies had strong evidence for the claims. The scientists themselves, though, also exaggerated, with 20% of the studies claiming to have strong evidence when they really didn't. So I want to be clear, the blame cannot be placed solely on journalists. Exaggerated headlines and poorly chosen images are only part of the chain of exaggeration. A scientific study may indeed have an interesting but small finding, which is exaggerated a little bit by the scientists in their paper. It's then exaggerated sometimes quite a bit more by the university press release. It's then further exaggerated by journalists and editors, especially in the headline. And then it's exaggerated even more when presented on social media. Excuse me. And this chain of exaggeration amplifies fear, and loses the nuance and context that's necessary for people to understand what the risk actually is. It turns something that is interesting, but relatively minor, into something that sounds like a disaster. Now, the chain of exaggeration typically starts with a single study. Again, single studies may be interesting, but they are usually not enough to prove that a risk or a benefit exists. You may have seen this excellent graphic from Vox in 2017. As Julia Belluz reports, everything both causes and prevents cancer. Here is a grocery list of common food items: wine, tomatoes, tea, milk, eggs, corn, coffee, butter, and beef. We've all eaten some, if not all of these. For each of these foods, for each of these foods, there exists multiple studies showing that it causes cancer and multiple studies showing that it protects against cancer. The actual risk of each one of these foods isn't described by any single one of these studies. Instead, scientists need to look at overlapping studies on a given topic to find some consensus. So why do single studies get so much attention? Naomi Oreskes, professor of the history of science from Harvard University, told journalist Julia Belluz in an interview, "What makes it news is that it's new, and that creates a bias in the media to look for brand new results. My view would be that brand new results would be the most likely to be wrong." Clearly, Dr. Oreskes' wise words apply quite thoroughly today. During a public health crisis, information is flying faster than it can be analyzed. Scientists, medical professionals, politicians, journalists, and others are all anxious to help, and many do have incentives to provide the information first. These strong incentives to provide information quickly result in an onslaught of data that most of us can barely keep up with, let alone make accurate conclusions about. Our unprecedented connectivity means that a single study can be reported and re-reported many times before it's even been peer-reviewed. And while that's been frustrating at times, I do want to note that overall, I've been pretty impressed with how the media has been communicating about this crisis. There's been a lot of very strong fact-based articles. Also, political, religious, and other motivations can be strong incentives to provide alternative information that runs counter to facts. So with all of this going on, how can we identify quality information about coronavirus and any other health topic? A pyramid model is often used to show quality of information. There are many versions, but generally you have lower quality studies at the bottom and higher quality reviews at the top. At the bottom of the pyramid, you'll find opinions, single case reports, testimonials. These do not provide an objective picture and do not take enough evidence into account in order to make a conclusion. They are interesting, but do not prove that a risk or a benefit exists. Next are studies in vitro, conducted on isolated cells that behave differently than cells in a body. In vitro studies can be a very helpful and important step of research, but they don't prove causality. If you add a substance to cells in a petri dish, you may see some response, but exposing a whole plant, animal, or person to the same substance may result in a very different outcome. A little better are in vivo studies, which are on whole organisms. These at least look at a whole biological system, but often a model organism is used that may not apply in the real world. For example, studies in mice can be very important and very useful, but they don't necessarily tell us how a human will react. In vivo and in vitro studies can provide needed information, but are still limited to describing the situation that is in the study. Next are studies that are actually on the organism that you're looking at. In the case of human research, that means epidemiological studies that look retrospectively for a connection between exposures and outcomes, or controlled trials that look proactively for such a connection. The best studies on this level of the pyramid are double-blind, placebo-controlled studies. Still, even the most well-done study may leave some areas of research unexplored. Single studies, again, do not prove causality. And keep in mind that depending on what you're studying, not all types of studies are possible or even ethical. Next are systematic reviews and meta-analyses. Both combine data from multiple overlapping studies on similar topics. A systematic review methodically looks across the scientific literature and summarizes all of the knowledge on a topic. Government risk analyses can be a type of systematic review. A meta-analysis uses statistical methods to summarize the results found in the review. Now, systematic reviews and meta-analyses can provide stronger evidence for causality between a potential cause and effect, but we still have to be critical because some systematic reviews and meta-analyses are more careful than others. Some only include certain types of evidence, and we need to be sure that they include all relevant evidence, including multiple types of studies. Now, the best evidence leaning towards consensus on a topic is when we have multiple systematic reviews and meta-analyses on related topics. That's what you want to look for. That's the gold standard. So let's consider a case study on the commonly used herbicide, glyphosate. Numerous national and international risk assessment agencies have conducted very thorough risk assessments of glyphosate, looking at all of the evidence in the literature, and they've found it to present a low risk to human health or the environment when it's used in accordance with the pesticide label. But in 2015, the International Agency for Research on Cancer, IARC, which is part of the World Health Organization, declared that glyphosate was probably carcinogenic, and they set off a lot of things. So Andrew Niss, a weed scientist at the University of Wyoming, put together a version of the Vox graph. But this version considers some of the many studies that have been conducted to determine whether glyphosate is associated with various cancers. You'll see here that glyphosate both causes and prevents cancer, depending on which study you're looking at. If we were to only look at a single point on this graph, we might conclude that glyphosate causes or reduces cancer, but we need to look at the full picture. To get back to IARC, they use a hazard-based approach that does not consider exposure. Despite their hazard-based approach, the news media and many activist groups have seized on the IARC report. They're still talking about it. So during the European Union's reapproval process for glyphosate in November 2017, French media and other media published many articles about glyphosate. In an analysis of 81 randomly selected articles, 73% were found to emphasize the IARC report. Only a few of them cited risk assessments that had been conducted by European risk assessment agencies that found glyphosate to pose a low risk. And none of those articles in that sample set cited any of the national and international risk assessments that had been done on glyphosate. Further, none of these studies reported what would happen to farmers or the price of food or anything else if farmers had to switch from glyphosate to other weed control methods. They didn't look at alternatives. Finally, only 7% of the analyzed articles actually cited an expert, while 41% cited an activist source. So how can people understand risks when they don't have all of the evidence? In this example, many articles didn't cite the information that was available, and that gives a skewed picture of the risks. So how can we identify the best evidence? To go back to our pyramid of evidence, many international and national risk assessment agencies conducted those thorough risk assessments. It's equivalent to a systematic review or meta-analysis. And all of them came to similar conclusions. They determined that glyphosate presents a low risk when used in accordance to the label. So they've effectively gotten to the top of the pyramid. Now, how various governments have used this data in policy is another question, but the science there is sound. This example shows why it's so important to check information before believing it. SciMom Allison Bernstein lists some reasons why we list some questions that we should ask to assess whether information is reliable. First, are other people reporting similar findings? And where are the findings being reported? Second, is there a consensus on the topic? And does the article go against the established consensus? Third, what sources are they citing? And be sure that all the articles don't point to a single source. Fourth, is the information based on a single study, or are there many studies, like in our pyramid of evidence, pointing to a similar conclusion? Lastly, and perhaps the most relevant today, does the article sound too good to be true? We all want there to be some easy cure that will banish the sickness and bring our lives back to normal, but things rarely happen that way, and we can't expect it to. So that's all I have for now. So I look forward to all the questions that you have. And if you'd like to discuss anything further, I want to point you to our websites. And you can also find me on Twitter or Facebook. So I look forward to talking with you.
Thank you, Anastasia. Let me remind folks how to submit questions. To the right of your video display is the live chat window. Go ahead and type questions in there and I'll read them off to Anastasia. We already have a couple here. Oh, and if you would post what your city or town is. And we have a question from a few minutes ago about the Guardian headline that you mentioned. Can you jump back to that slide, please?
Oh, yeah. I think I can do that. Give me 1 second. Pull that up and share my screen again. There you go.
Yes. Okay. So the person asking the question said that the headline didn't actually say what you said it did, although I'm not sure how we can check on that right now.
I said that the article said that pesticide was found in children's breakfast food.
Okay.
I think I did. Yeah.
All right. Yeah, I guess this article is somewhere online, and if there's any question for our person that asked that, I guess we can check that independently later on. Let's see. Next question. This is from Bruce up in Ellicott City, Maryland. When most people receive scientific information through a political or media lens, what are scientists doing to help people get better information?
Oh, that's a great question. Thanks, Bruce. So I think that the risk communication landscape has changed a lot over the years. Of course, if we go back to the days before social media or the days before science blogs, the only people who were really doing communicating were journalists. Those were the people who had the platforms and the ability to reach people. But now, with the advent of social media, you can actually reach out and talk to scientists yourself. I see a lot of scientists posting on Medium or on their own blogs or various places online about the science themselves. And so you have an opportunity to both look at what journalists are saying, what politicians are saying, and then what the scientists themselves are saying.
All right. Our next question, I'm not sure where this is from, asks, didn't Monsanto, the big corporation, get in trouble because they had internal documents showing that they knew glyphosate caused cancer from over a decade ago?
Yeah, so there's a lot of interesting information out there about the communication strategies that the company Monsanto, which doesn't exist anymore, used. And I guess at the end of the day, what's important is that we look at the science. Different people have different motivations, especially when they're trying to communicate about a product that they sell. But if we look at independent science sources, they show that the risk of glyphosate is low. And I can direct you back to that slide. Whoops. There we go. I can direct you back to that slide that showed Andrew Nissa's excellent graph on glyphosate. Sorry about that. There we go. And so there have been a lot of different studies. Some of these were conducted by industry, and some of them were conducted by independent sources, government agencies, or academics that receive government funding. And as you can see, there have been studies that show various things. Some cancers are decreased by glyphosate, some of them are increased by glyphosate, and it really all depends on what study you're looking at. And there are a couple of reasons for that. One reason is statistical variability. So if you do an experiment on too small a sample size, if you don't have enough rodents in your study, then you can get incorrect results. Or if you're testing too many things in the same sample, if you have a group of rodents and you're measuring 100 different factors on them, then some of them, just by chance, are going to show a result, even if that's not really there. And so we have a couple of pretty broad issues, depending on what subject matter is being studied. And so I think that's why it's even more important to go back to that pyramid of evidence and see if you can find systematic reviews and meta-analyses, preferably more than one, that look at the whole body of evidence, determine how the methods of each study were appropriate or not appropriate, and then come to some conclusions based on the entire body of data.
Okay. By the way, you mentioned about small, say, rats, only a relatively small number of rats being involved in a study. Mm-hmm. That actually came up in our February lecture on 5G, the potential health risks. Oh, yeah. We canceled our March lecture because of the not being able to have public gatherings. But interestingly, in a way, both our consecutive lectures were on health risks. And let's see, our next question is from Beth in Washington, D.C. Do you have any thoughts on the litigation that ended with jury verdicts based on glyphosate being a carcinogen? Was that just bad lawyering? And how can it inform our communications?
Yeah, I think that it's important to remember that there's a really big difference between how scientists consider evidence and how juries consider evidence. There's a lot of power in the way that the United States handles our court system, the way that evidence has to be presented to a jury of your peers, and it's all fundamentally incredibly important and has many years of history behind it. But when we get to scientific questions, oh, sorry, I think a cloud's moving in front of my window. So when we get to scientific questions like, does glyphosate cause cancer? It's something that is very difficult to have a court decide, to have a jury of non-scientists or maybe only a few scientists in a group decide. And this is incredibly complicated information. And not only is the science complicated, there's also a whole host of information about social and economic and political issues that are going on when you talk about something like a large company, any large company, being involved in something that's so fundamental to our lives like food. So the trials are interesting, and I hope that the people who are sick, are able to find some sort of solace. But at the end of the day, if we want to evaluate the science, we have to go back to the risk assessments and back to the systematic reviews and meta-analyses and look there. Don't look at the court cases if you want to know what the science is.
Okay. Let's see, our next question. Would you comment in the way that you did about the glyphosate studies? What is the best evidence on BPA?
Yeah, so that's actually not like a strong area of my background, but I definitely encourage you to look for systematic reviews and meta-analyses on that. It's still an emerging area of science. Endocrine disruptors in general is an emerging area of science, where the science is saying that potentially small amounts of a substance could have a fairly large impact on our human health. But practically speaking, when it comes to each of our individual exposure, from what I've read and what I've looked into, if you are not microwaving plastic, if you're just using plastic in the way that it's intended to, do your microwaving in glass or other types of containers, then you're dramatically reducing your risk. And at the end of the day, it's far more important for you to focus on the trees in that landscape of risk. If you are exercising, if you're eating your fruits and vegetables and things like that, then relatively minor risks like potential BPA exposure from handling a receipt for a second before you put it in the trash is not really going to impact your health.
Okay. By the way, quick question for me about your diagram with the trees and the grass risks. How was that sorted out? Was there a particular reference?
Yeah, so let me pull it up really quick. Where did I have that at?
There it is.
There we go. So if you go to this address at the bottom, SciMoms.com/0-risk-impossible, there's a lot more information about how that particular graphic came to be created. So you'll note that at the top it says not to scale. In general, it's looking at the particular risks that are in our daily lives that have been shown to have a relatively large impact on human health.
Mm-hmm.
And I also do want to point out that this is average risk for people that have, average exposure. It's not necessarily talking about occupational exposure. Right. So you could have someone who is in a developing country where they don't have as strong of pesticide laws and they're applying pesticide on a daily basis without the appropriate protective equipment, then obviously that risk is going to be quite a bit larger than it is portrayed on this not to scale graph. Mm-hmm. But in general, for most of us, not eating enough fruits and vegetables, not exercising, smoking, heavy drinking, and exposure to air pollution are going to be the biggest risks to our health in our daily lives.
Mm-hmm. All right, next is a comment for you to consider for us from Richard in Portland, Oregon, who is now the record holder for our most distant attendee at an NCAS event. He notes that science seldom offers absolutes, and some folks do not like that. I assume that problem occurs for science communicators and ones that maybe aren't very good at communicating science, to try to discuss probabilities instead of absolutes and so forth. What would you say about that as a difficulty for science journalists and so on?
Yeah, that's 100% correct. When scientists talk to each other, we use a lot of words like we talk about the probability that something might be happening, or we couch things in the data shows that, this could be an effect, things like that. And so it can sound really wishy-washy, and it doesn't translate well into, how most people think about things and most people read information. And that can be a huge challenge. I think that a lot of, just starting out science communicators, especially people who are trained in the sciences, they'll try to talk to a journalist and provide some great information, but they're giving it in that science speak. And then the journalist has to interpret, what they're saying. And then there might be some inexactness that comes out in the resulting article. So there's a ton of challenges. And I think the most important thing is just to keep in mind that there are few absolutes. So if you read an article, as a layperson, you read an article that says, this causes this. It doesn't. I mean, it's very, very unlikely that definitive statement is true, because we know that there's overlapping evidence for most things. Now, there are a few, of course, like that air pollution and eating enough fruits and vegetables, if I may harp on that, where there is enough evidence. There's decades of study in many different ways and different populations and in animal studies and in human studies that show that, certain things are risks or benefits. But for the most part, when you're talking about a certain question, it's hard to say no absolute.
Yeah, so I think it's fair to say that science moms and non-science moms all want their kids to eat their vegetables. Is that right?
Yeah.
Okay.
Although, it's easier said than done.
We have a question about 5G. And of course, that's not the topic for today. It's a health risk that's been put out there as a claim. I will say, I know the person, Rich, that posted this question, and I'll send him the information about our February lecture.
Great.
Let's see, Maxwell up in Bethlehem, Pennsylvania asks, isn't the real measure the quality of the research, not the number of publications? Many flawed studies should not outweigh a few sound, better quality studies. What are your thoughts on that?
Yeah, definitely. That's definitely right. And I'm sorry if I implied anything different. So in a systematic review or a meta-analysis, most of the time, if it's a well-done one, they'll start out by setting some methods. They'll set parameters for studies that they will include or not include in their systematic review. And so oftentimes, if you're reading one of those types of articles, systematic reviews or meta-analyses, you'll see where they'll say, we didn't include such and such study because, the sample size was too small or it wasn't long enough or whatever reason. And so those are looking at the quality. And that's why I keep talking about those. If you're a non-scientist and, you might not know all of the ins and outs of which type of study is the best well-done study, as a plant geneticist and working in risk assessments, I've gotten a pretty good body of knowledge about how to analyze different types of studies, but there are still many that baffle me. I'll try to read the methods and I just don't have experience with them. And so for me to try to evaluate a study that's outside of my field is very difficult, even as a scientist. And so I want to turn to a systematic review or meta-analyses that has been well done and looks at the quality of studies before they add them to their review, and then look at what their conclusions are.
Let's see, Bruce up in Ellicott City asks another question. Are you considering looking into hydrochloroquine? He says, talk about the intersection of anecdote, poor studies, politics, media, uncertainty, and fear. Don't you think this would be an interesting case study?
Yeah, I think it would be an interesting case study in a future talk like this. It's still pretty new, happening right now, but I did, sort of mean to allude to that on that one slide that I showed about coronavirus. I think that the current situation is it's not unique, but it's certainly exemplary case of where we have things that are moving so quickly that the research is not able to keep up. And then usually, in a lot of cases, there'll be some political or economic or different motivations involved. But the motivations around the current pandemic are so strong and so diverse that evaluating one scientific study, one finding that actually I don't even know if it's been published yet, we're getting ourselves into a lot of trouble, moving too fast on something that we really need to get better evidence for before coming to a conclusion.
Yeah, we're in the fog of war here. Things are moving so quickly. I did want to make a comment here that we're now almost a week since the most famous ICU intensive care unit survivor of the virus was released from the hospital, or as they say in Britain, from hospital, Prime Minister Boris Johnson. And last time I checked, which was maybe a couple of days ago, I don't think anyone in the news media has asked a very obvious question. What were the treatments used to save his life? Was hydrochloroquine in there? Just curious. It's interesting that as far as I know, no one has asked, hey, how did you save our prime minister? Of course, there could be confidentiality issues and things like that. But anyway, Let's see here. Someone said not something nice about me. I'm too modest to say it. Let's see. Good point here from Beth in Washington, D.C. Tom Hanks is more famous probably than Boris Johnson, she says. He did recover. I'm not sure he was in intensive care though. That was, I think the more relevant point I was trying to make.
Where Johnson's case was more serious potentially.
It seems so, yes.
Yeah.
Yeah, I did have a comment also, and that is, this is actually kind of fun for a lay person to do, and that is to compare a headline with the article and find contradictions.
Yeah.
Or let's just say, that they had no choice but to put it in sort of a clickbait form.
I mean, that happens, yeah.
Yeah,
There's
it's
a lot of motivations, a lot of different reasons why that happens.
yes. And you showed that beautiful chart of information coming from scientists through the university press release over to, eventually social media over at the right. And yeah, when I see a news article, I automatically go find the press release from the university to try to get a step higher. And then I go back to the original article. And of course, I'm out of my depth usually when I'm looking at it. I can sort of make my way through it. But as you mentioned, in your case, when you're a non-expert on something, it's good luck. I guess the best I do is the press release from the university. Let's see, Bruce pointed out that Rita Wilson, that's Tom Hanks' wife, was treated with hydrochloroquine, and she said it had bad side effects, and it wasn't obvious whether it helped. Of course, you never know when you have a treatment whether you would have gotten better with or without it, or so that's true.
Oh, I wanted to go back to that previous comment really quick. So looking at a headline versus the content of the article, that's across the board. That's not just when we're talking about science, right? Oftentimes there'll be a headline about a political issue or an economic issue or really anything. And what is at the top might not necessarily match what's in the article. So we have to be careful.
Mm-hmm. Another comment, if I may, I'm still waiting for other questions. I guess I have the microphone until then. That was, right now we're trapped in a scientific crisis, a health science crisis.
Yeah.
And our generals are Dr. Birx and Dr. Fauci, and then, their colleagues that we don't see as often. And they interact with the news media at the White House pretty much every day. And I noticed that the news media outlets haven't sent science reporters in there. They continue to use their routine White House press conference reporters, which have a different type of skill set.
I hadn't noticed that. That's an interesting observation.
And I actually shot an email to Joel Achenbach, who knows us. He's the Washington Post, one of their science reporters. He's done programs with us. We gave him an award. He's such a good science communicator several years ago. And said, hey, could you, slip a good question or two to your White House colleague from the Washington Post? And it's a little frustrating to watch. They have a different type of thought process when they form questions.
Yeah.
And a lot of times it's not really focused on, hey, how do you solve these problems scientifically? It's usually sort of general logistical, why aren't there more face protective masks for healthcare workers and so on. So anyway, I hope slowly more science reporters will be interacting. I should say though that obviously they invite Dr. Fauci and Dr. Birx on their programs. So it isn't just in the White House that they can communicate with the public. Let's see, back to questions.
Can I add something to that really quick?
Oh, sure.
So I just wanted to point out that there are other information sources in the US that I think are really important. There are public health experts in every state that are communicating that are actively involved with the governors and other officials in their states. And so their political and economic motivations in each state are going to be a little bit different, but they all have at least one, oftentimes many more than one, scientists and public health officials who are interpreting the data themselves in different ways than might be being done at the national level. So I think it's important to listen to not just what's coming out from the national level, but look at your own state and other states as well.
Oh, yes, I sent that out to all my relatives that live in various places in the country, for their public health officials in their state or even county that they should.
Yeah, exactly.
Someone whose username is Cursus Publicus, maybe coming from ancient Rome, I don't know. He says editors often create clickbait headlines that the author of the article, they wouldn't have signed off on it. It's not their fault, it's the editors. Let's see, another person posted, this is Walter Rowe, forensic professor over in Virginia. He says, are you familiar with the Cochrane collaboration? What do you think of their meta-analyses?
Yeah, that's a great point. I was considering whether to mention them in this talk, and I wasn't sure if that was outside the scope, but yeah, Cochrane does as far as I know, an excellent job of combing the scientific literature on a topic and putting out a document that summarizes it all. They focus on health topics. So if you Google Cochrane reviews, you'll find their site, and they generally have a large body of knowledge that can be really helpful.
Mm-hmm. I remember the noted skeptic Ray Hyman. He's now emeritus professor of psychology out in University of Oregon. His opinion was that meta-analyses are great for hypothesis development. Any thoughts about that? That maybe they shouldn't be used for more than hypothesis development?
I'd have to look more into why he said that.
Mm-hmm.
I mean, in science, every time you answer one question, it raises 10 more,
Mm-hmm.
right? That's how we advance science. And so I'd say that if you're looking at the body of knowledge and putting it together into a meta-analysis or systematic review, then you're finding out what is the best science, hopefully, if it's a well-done review. What is all of the information that's available, say, what's the conclusion? And then you can go from that point to decide, well, where should we look next for more information?
Mm-hmm. Okay. By the way, I should note there's plenty of compliments here for you, your presentation and your
that's very nice. Thank you.
Here. Let's see, Melissa in Arlington, Virginia. She says, perhaps the most serious issue now is the lack of respect for expertise, especially scientific expertise. Any suggestions on what needs to be done about this?
Yeah, it is a really huge problem. And I think that there's a lot of reasons for it. And I think it's going to be many years before this problem is really resolved. And it probably goes back to science education for children. But right now, at this point, I think that what really matters is for experts to develop trust with their target audience. Yes. And that's exactly what we're trying to do with SciMoms. Just coming out and saying, I'm a scientist and you should listen to me because of this, that's not going to help anybody. Mm-hmm. But when we come out and say, I'm a mom, my kid is going to go to a party that has trampolines. Is that safe? I need to look into that and make sure that I'm comfortable with that situation. And so on the SciMoms website, you can find an article about trampoline safety. And most of the questions there are coming from either ourselves as parents or from other parents who are asking questions that we've then researched. And we're really working hard on developing that trust, finding common concerns with our audience and showing that we're not up in the ivory tower. We're crawling around on the floor with our toddlers, just like you are. So we just have a different way of looking at information that we're able to then bring to people. So I would say for any science communicator or burgeoning science communicator out there, that starting with your audience building is often the most important. Finding out who you want to talk to and how you want to talk to them is just as important, if not more important, than what you talk about.
By the way, a thought I have about scientific expertise in the news recently was, as you may remember, the CDC originally said, hey, don't wear any masks for obvious reasons. Healthcare professionals need to have them. Don't wear face coverings. And then they changed their minds later, and one would have hoped that they had kept a consistent message, and presumably they have the right message now of wear face coverings. It might help a little, and yet that does make it look to non-experts like, hey, we were talking about this 2 weeks ago on social media, and they were. And they were looking at what's happening in other countries that were ahead of us in the virus epidemic, and seeing that their local governments were saying wear face coverings, it'll help some. So anyway, I think that might be part of the reason. There are occasions where experts turn out to either be wrong or there's some sort of inconsistency. And in this case, it may have been for your own good type thing. Please don't try to wear masks, or don't try to get closer than 6 feet, even though you're wearing a face covering. Anyway, obviously this is, happening in the here and now, but did you have any thoughts about how CDC changed course really 180 degrees over a period of just a few weeks?
I think that there's some specific difficulties with public health recommendations above really anything else. Public health, the topics that they address are intimate, right? They have to do with aspects of our daily lives, how we cook our food, how we keep ourselves safe in different ways. And public health recommendations are often quite broad. And so they have to weigh risks of an intervention along with the benefits of an intervention. And so in the case of face coverings, it's complicated, right? Like if you're not wearing it properly and you're going out and not following our physical distancing recommendations, then you might be exposing yourself even worse than you would have if you'd have just stayed, further away from folks. And so, I'm not at CDC, and even if I was, I wouldn't be able to talk about that because it's all happening right now. But I can imagine that there were probably a lot of different things that they were considering when trying to decide what recommendations to make, and the benefits were not yet outweighed by the risks a couple of weeks ago. And then as more information became available about airborne transmission and the inability of so many people to do proper physical distancing, like restaurants are still open. What do you think the kitchen looks like? They can't stay 6 feet apart. So in those cases, wearing a mask is important. And so they've had to adjust their recommendations. And I wouldn't necessarily say it's a 360. I think it's adapting in the face of additional evidence, which is a good thing.
Yeah, they've also put out good guidance on how to make homemade face coverings.
Yeah.
Let's see, Richard, I think this is our Portland, Oregon guest, mentions BIER reference data. I don't know that. What is it?
I'm not sure.
Bravo, India, Echo, Romeo, beer reference data. Maybe he can post more information about that later on here.
It doesn't ring a bell right now.
Let's see. What is Battelle Institute? I don't think I've heard of that.
Might be getting
Battelle Institute has great reference data hosted from a few universities, Richard of Portland says.
Okay.
Let's see.
So I guess if we're talking about sources, I think another good one is extension. I mentioned that as one of the risk communicators on one of my slides. And I think that it's a great resource that people can keep in mind. They do make some public health recommendations, especially when it comes to food and cooking and using pesticides safely and things like that. And if you look at extension, they often have locally relevant information as well as consensus type information from across the country.
Mm-hmm. Let's see, Marv up in, I think, Columbia, Maryland, notes about the masks that they're really best to protect if the wearer is ill, you know, a carrier, that if they wear a mask, it makes transmission much less likely rather than a healthy person wearing a mask not being exposed to the virus.
Yeah.
Let's see, one of our earlier questioners where I didn't know where he or she was from says they're from Toronto, Canada. So we have our first international NCAS participant. Congratulations. I don't think we have a prize for you. I think, isn't the border closed off, but we wave to our neighbors far to the north here. Thanks for hopping on with us. Yeah, and as Jeff from Wheaton, Maryland notes, CDC was trying to make sure that the healthcare workers would get the masks rather than, you know, the run on toilet paper and so on. We've already seen what happens when an idea gets into the public's head.
Gloves are another one. I was at the grocery store and I saw a ton of people wearing gloves, touching their phone, touching their faces.
Oh, yes. How to not use gloves and then to tear them off and leave them in the parking lot. Right, okay.
Yeah.
Someone from Scotland is here, so overseas. And what is that, 7:30 in the evening there? Good evening, Scotland. Let's see. I'm trying to think if I have any other questions. Well, the well is a little dry here on our chat window.
Well, I mean, if there aren't any more questions, we can always stop here.
Yeah, we're exactly an hour in.
Great.
Normally, we would wrap up with a social time and, you know, have coffee and various refreshments and shake hands and so on. It's going to be a long time till we do that. But, you know, hopefully we'll go through these CDC guidelines, each community. And there's what they call the gating criteria to get through to phase 1, and then gate through again to phase 2, and then later phase 3. And hopefully the vaccine will come out and it'll be effective and widely distributed, and we'll have normal lives again.
Great.
Obviously, I hope everyone that's participated with us today, that you and your loved ones are safe, both health-wise and in your livelihoods. And I'm really glad that we were able to do this today. In a way, it's sort of our way of fighting back against our hardships. We were still able to have our event today.
Indeed. Thank you so much for inviting me. I'm really glad, and I'm happy to come back and talk anytime.
Delighted, Anastasia. You did great. And
thanks.
what I was just trying to imagine what it would be like if I gave a presentation when I do work presentations over at NASA here. I can see their faces on my screen, and here you were flying blind, but you did great. I was
definitely a different
getting good questions and compliments. So
Good, good. Well, then in closing, I just wanted to note that both on biofortified.org and SciMoms.com, we have contact forms.
Mhm.
So if you have particular questions or especially in the case of SciMoms, a topic that you'd like to see us cover, then just let us know. We have a long list, but we're slowly working through it. We also accept guest posts on both sites. So if there's something related to food and ag that you'd like to write about or something relevant to parenting, please let us know. We welcome guest experts. And of course, you can find both organizations on social media.
Wonderful. And let me give quick thanks, very important thanks to our producer, JD Mack, and also Chip Denman that did some technical problem solving for us to prove that we could actually pull this off today. And I really appreciate that. And again, thanks to everyone. Be safe. And we may be back. I don't know when, but we'll do another online event, and hopefully in the not too distant future in person, with our speaker from March from the Science Channel. It's going to be a great program. And thanks again, Anastasia, for a great program today.
Great, thank you.
All right, bye-bye.